A high-precision gear is functionally useless if its teeth fail to catch the drive shaft. It spins flawlessly, generating motion, but transferring zero power. Modern educational technology frequently suffers from this exact mechanical failure. We build pristine, broadcast-quality videos and frictionless apps, assuming that aesthetic polish guarantees knowledge transfer. It doesn't. Refining an isolated instructional artifact, the video, the quiz, the reading assignment, rarely produces behavioral change in adult learners on its own. This disconnect stems from a widespread identity crisis in the training industry. Organizations routinely conflate two completely distinct operational disciplines: instructional design and learning experience design. Treating these terms as interchangeable synonyms leads to misaligned hiring, curricula that look good but fail to teach, and a reliance on deceptive engagement metrics. To engineer effective adult learning, we have to transition from designing isolated artifacts aimed at passive objects to architecting comprehensive ecosystems built for active agents. Establishing the precise scientific and operational boundaries between these two fields is the prerequisite for generating actual educational return on investment. The structural differences between these disciplines originate in psychology. How a course is architected depends entirely on how the designer perceives the human brain. In the early 20th century, educational theory treated the learner as a passive object. The prevailing idea was that a student's will should be softened until they became an empty, receptive vessel. We see this mindset in early 1900s illustrations predicting the future of education. Knowledge is ground up and fed into students' brains through mechanical wires. This object-oriented view was codified by the psychological school of behaviorism, which modeled human learning as a biological sequence of stimuli and reinforced reactions. Following the conditioning principles established by researchers like Ivan Pavlov, the logical conclusion was that human learning could be reliably controlled from the outside. This established the foundation for traditional instructional design. The operating principle is straightforward. Engineer the correct stimulus, the perfectly crafted instruction, and the learner automatically absorbs it. Eventually, this gave way to an opposing framework known as constructivism. This model views the learner not as a passive target of instruction, but as an active subject who constructs their own meaning through direct interaction with their environment. Elements of this philosophy emerged from unconventional 19th century experiments, like Leo Tolstoy's peasant school at Yasnaya Polyana, where independent exploration took precedence over rigid instruction. When we treat the learner as an active agent, the designer's role moves from content narrator to environmental architect. We are no longer simply sequencing information. We are building the space where that information is applied. When these two psychological frameworks collide in a modern corporate workplace, they produce two distinct operational roles. Early organizational learning evolved within highly structured, artifact-driven training environments. Methodologists focused strictly on optimizing discrete teaching moments, like a lecture or a printed manual. Today, the instructional designer retains this highly focused tactical scope. They are responsible for the meticulous execution of specific learning materials. This diagram illustrates the divide. On the tactical side, instructional design delivers concrete artifacts: video scripts, comprehension quizzes, reading materials, and presentation decks. The learning experience designer operates at a higher altitude. Their mandate is to architect the overarching strategic ecosystem and map the psychological journey. On the strategic side, deliverables are systemic, managing cognitive load limits, establishing tutor protocols, and building motivational scaffolding to prevent dropouts. One discipline does not replace the other. Strategic design relies entirely on the tactical foundation of constructive alignment, the strict correlation between educational goals, methods, and testing. Tactical instruction acts as the rigid core, while experience design functions as the dynamic, orbiting ecosystem adapting to learner friction. Assigning a tactical instructional designer to architect a systemic ecosystem, or asking an experience designer to simply format slide decks, guarantees organizational dysfunction and educational failure. Even when an organization correctly deploys an experience designer, they often run into a significant operational hazard: the assumption that learning design principles apply universally to every subject matter. This visualization shows how educational methodology is structured. The thick outer ring represents universal principles of learning. These biological and cognitive rules govern how the brain processes information, dictating working memory capacity. Because these are biological, they exert the same pressure universally, whether studying culinary arts, world history, or physics. However, understanding memory doesn't tell you how to teach the logical structures of a distinct discipline. That requires the inner core, content-specific methodologies. Ancient disciplines, like mathematics, possess thousands of years of accumulated didactics. Rapidly evolving fields often lack these guidelines. Consider software engineering. Teaching Python demands highly specific coding exercises. Universal design keeps the course engaging, but domain-specific didactics actually impart the skill. A curriculum that relies entirely on universal experience design while ignoring the specific methodologies of its subject matter will feel entirely frictionless to the student, yet fail to impart any actual proficiency. Once this complex ecosystem is deployed, determining whether it actually functions requires looking at the data. At this stage, the most dangerous architectural error designers make is confusing the metrics of the product with the metrics of the instruction. This diagnostic model untangles the information flowing out of a course. It takes a single, chaotic stream of user behavior and splits it into two distinct categories. The first category tracks completion rates, session duration, and raw user engagement. These are product metrics. They function as retention and marketing indicators, measuring how successfully the software holds the user's attention. The second category tracks assessment pass rates, task accuracy, and demonstrated behavioral change. These are educational metrics. They are the only data points that quantify actual knowledge transfer. This separation establishes our first operational guardrail. A high completion rate proves the ecosystem is sticky and the learner stayed in the room. It offers zero proof that they acquired the target skill. This leads to the second guardrail, avoiding trends. Injecting gamification or heavy entertainment value specifically to inflate product metrics often dilutes the rigor required to achieve true educational outcomes. The final guardrail here is systemic flexibility. If educational data reveals that a specific method, like case studies, fails to produce competency, the designer must pivot to alternatives, like problem-based learning or live simulations. Effectively pivoting mid-course relies on systemic thinking and strategic foresight, qualities that go beyond navigating a piece of authoring software. Designers must be willing to dismantle failing structures and rebuild based on the evidence. Engineering a successful curriculum requires moving past the superficial aesthetics of engagement. It requires designing environments for active subjects, aligning to the specific didactics of the discipline, and demanding hard proof of actual competency over mere attendance.